Hello everyone and welcome back. We are doing capacity planning and productivity management. We are done with capacity. We are doing a few questions from productivity, but because I told you a few questions are mixed, it's a little difficult to judge between capacity and productivity. So I've kept both the concepts as the same. We are moving on into the next concept. We are done with productivity which is of two types. There's input output and output output. The next thing that we are going to do is efficiency and utilization. Now, efficiency and utilization are nothing else but again productivity only, but calculated in a different way or with a different approach. What is that? Let's look at a question and then only directly give you an answer. The question that I want to do is question number 3. A steel plant has a design capacity of 50,000 tons. Effective capacity of 40,000 tons and an actual output of 36,000 tons per day. Compute the efficiency of the plant and its utilization. So, there is a steel plant. Now, I hope you know what a steel plant is, where iron ore comes in, and from iron ore we melt the ore, and then at different temperatures we pull out different metals. We pull out steel, we pull out iron, we pull out some amount of other elements, which is copper also might come out of it. So we distribute them at different levels. So this is basically a furnace or a plant which is designed to process steel. They have given you a design capacity of 50,000 tons. What do you mean by design capacity? When I went to buy this, let's suppose this is a machine which can process 50,000 tons of steel. When I went to buy it, they told me that in one day it can process 50,000 tons of steel. That is what the design says. But the effective that you get is 40,000 tons. But the actual that you get is only 36,000 tons. What does this mean? I'll give you a better example or a relatable example. We all have seen cars and bikes. Suppose there is a new bike that gets launched into the market. Now, what are the main features of a bike that you go to see? What cc engine it is, or a car for that matter, what cc engine it is, what mileage does the bike give? So, I heard that the designed mileage or the company mileage that we call it of this bike is 100 kilometers per liter, or also written as 100 kmpl, 100 kilometers per liter. So in 1 liter, this bike runs 100 kilometers. There is a person who's bought the bike. So the company is written 100, but the company writes anything that they want to. And I'll tell you why they get 100 kilometers per liter mileage. That person that I spoke to told me that you don't get 100 kilometers per liter, you get around 80 kilometers per liter, or I am getting around 80 kilometers per liter. Okay, I buy the bike. And I end up getting only a 70 kilometers per liter. This is the design. And you know how this is found? What they do is they take a small bottle of 100 ml petrol and they connect it to the fuel in. They make the bike stand on the main stand where there is no friction in the tire behind, and they keep running the bike. Whatever it runs in 100 ml, multiply that by 10, that much what it will run in 1 liter. Array, but there might be people sitting on the bike. Look at the roads that we have. You will brake, you will accelerate, you will change the functionality of the bike. Won't the petrol usage increase and decrease accordingly? Yes. So even though the company writes that the design created is for 100 kilometers per liter, the effective that a person who's bought the bike actually gets is 80 kilometer per liter. So I said, fine, as it is new that when a company writes 100 kilometer per liter, you don't get 100 kilometer per liter. I know you get less. But this person is saying he gets 80. 80 is also good enough for me. So I bought the bike. When I got the bike, I ended up actually getting 70 kilometers per liter. This is the design capacity, this is the effective capacity, and this is the actual capacity. Now, why is this happening? Well, again, when they say 100, you don't get 100, obviously, because they are doing this on a standard basis in a different way. When I actually start doing it at my place, it will be lesser. But then one thing, if he is getting 80, I should also get 80. Why am I not getting 80? Well, you are not getting 80 for different reasons. Number one, you as a person must be heavier than him. If you put more weight on the bike, it will take more energy to pull your weight. And if it takes more energy to pull your weight, it will eat more fuel. Or the road that this person travels on is a much better road as compared to the road that you travel on. That is why that person gets more mileage. He or she can keep a constant speed for a long time. You have to accelerate, brake. That ends up eating more fuel. And this is where we now start discussing efficiency and utilization. If I ask you, how efficient are you in using the bike? Well, I am using the bike for 70 kilometer per liter. But you should get paid 100. No, not 100. 100 is what the company is giving me. 100 I don't get. I agree, I should have gotten 80. So my efficiency should be what I get against what other people are effectively getting. And what is utilization? Utilization is what I get against the total. I don't care where the rest is getting lost. Find out how much are you short in utilizing the design. Well, I am around a 30% short, or I am only utilizing it 70%. 7 cancels, 0 cancels. 7 by 80 is 7 divided by 8 into 100, 87.5%. 87.5%. So my vehicle is 87.5% efficient, well, it is only 70% utilized. How do you compare this? You will compare what you are actually getting against for efficiency, what you are actually getting against what you should at least supposed to be getting, and for utilization, what you are actually getting against the total. So it is design, effective and actual. If you want to remember it as a formula, efficiency is actual divided by the effective into 100, and utilization is, actual divided by the design multiply by 100. Let's come back to the question. The design capacity is 50,000 units. The effective capacity is 40,000 units, and the actual is 36,000 units. Well, if you ask me how efficient am I in running the plant, well, I am getting a 36,000 where I should at least get a 40,000. So my efficiency in using it is 36,000 by 40,000 into 100. 36,000 by 40,000 into 100 is a 90% efficiency. And if you are asking me how well utilized I am, then I will say I am utilizing it only to 36,000 units against the design, which is 50,000 units. And that is 36,000 divided by 50,000. 36,000 divided by 50,000 into 100, which is 72%. So my plant is 72% utilized and 90% efficient. Let's come to the solution. So a steel plant has a design capacity of 50,000 tons, effective capacity of 40,000 tons, and an actual of 36,000 tons per day. Compute the efficiency of the plant and its utilization. Well, the plant is only 90% efficient and it is 72% utilized. What is efficiency? It is the actual against the effective. And what is utilization? It is actual against the design. That is question number 3. Let's come to question number 4. What does question number 4 say? Question number 4 is a very interesting question. And the question is, a firm has 4 work centers, A, B, C, D. Now what is happening? With individual capacities per day of shown in the figure. So let me quickly draw that. The raw material goes into A. A's input becomes B's output. A's output becomes B's input. B's output becomes C's input. And C's output becomes D's input. And D's output is the actual output. Okay. What else do I know? That A can process 380 units on a given day. So A can process 380 units, B can process 360 units, C can process 340 units, and D can process 400 units. And the actual output is of 300 units. This is from where the raw material goes in. What are you expecting from me? You are expecting 3 questions. Identify the bottleneck center. I will tell you what bottleneck center is. Number 2, what is the system capacity? And number 3, what is the system efficiency? Okay, I will tell you all 3. Let's deal with one at a time. I have 4 workstations. Now what happens is when a lot of people are working together. Let's imagine this as a normal criteria. Let's say this is a system of admission where A is buying a form, B is verifying the form, C is submitting the form, and D is getting an identity card. Correct? So on a given day, A can sell 380 forms, B can verify 360 forms, C can admit 340 forms, and D can give identity cards to 400 people. I agree with you. But you tell me, when 380 people actually buy forms on a certain day, will all 380 be able to verify forms? No. Only 360 will be able to verify forms. 20 people will be asked to come the next day. Okay. But the 360 people that get their forms verified, will all 360 be able to get the admission done the same day? No. Admission is a slightly lengthier process. Only 340 will be able to take admission. Okay. But all the 340 that take admission, will all 340 be able to take an identity card? Yes. I can give 400 people identity cards. So will all the 340 get identity cards? Yes. So 340 bought a form, but out of the 340 only 360 could verify it. Out of the 360 only 340 would able to take admission on that day, and out of the 340 only all 340 were able to get an identity card, which means my final output should be 340 admissions. Or in other words, A can process 380 units. But those 380 units have to be processed through B, no? B can also only process 360. So B won't be able to process all 380. B will only process 360. What about C? C can't process all the 360. C will only process 340. What about D? D can process all 340 because D can process 400. So the output will not be 400 or 380 or 360. The output will be 340. I'll give you a very good example of this. If you and your cousin, your nephew, your niece is walking on the road, on a footpath. Let's say your nephew or your niece is 4-year-old or 5-year-old, or your cousin is a 4-year-old or a 5-year-old cousin. You can walk at a speed of 9 kilometers per hour. Your nephew or niece can walk at a speed of probably half a kilometer per hour, because half the time they are pointing at stuff and asking you questions. Ye hara kyun hai, wo neela kyun hai, ye pagal kyun hai, and so on. So that takes a lot of time. My question to you is, can you walk at 9 kilometer per hour? Yes, if you pick them up and start walking, fantastic. Second option, if you can leave them and start walking, nothing like it. But that's not allowed, because whoever's kid that is when you go back home will beat the living daylights out of you. So you have to hold on to the kid and walk at their own pace. But I can walk at 9 kilometers per hour. Why do I walk at half a kilometer per hour? Because you don't have a choice. You are a team now. And when you are a team, you are as fast as your slowest companion. You are as fast as your slowest companion. Or your output is as good as your lowest output. Because you all are working as a system, no? If there is a person who can only process 340, then everybody can only process 340. Nobody will be able to process more than 340. Because imagine that this is making a table. So this is cutting a table, this is assembling a table, this is painting a table, and this is finishing a table. If I can only paint 340, how can you finish 400 tables? I can only paint 340 and give you. Then you can only finish those 340. So you are as fast as your slowest companion, or in other words, this is my bottleneck. What do you mean by a bottleneck? Well, a bottleneck is a very good term used on roads. Let's say this is a highway, and then suddenly it goes into a smaller road because now there are buildings on both sides. Doesn't this look like a bottle? And won't there now, so initially there were cars going in 2 lanes, now there are cars going in 1 lane. So won't there be a congestion at this point then? And this point where the congestion is caused is called a bottleneck. Why? What happens after that point? After that point, the speed with which you were processing before, you can't process with the same speed. If there were 2 cars every lane, now there is going to be 1 car every lane. And this is the point of bottleneck. What is the point that is reducing your production? Well, this is the point. Therefore, C is the bottleneck. So the bottleneck operation is C. Question number 2. What is the system's capacity? Well, there are 4 workstations. 1 workstation with 380, 1 workstation with 360, 1 workstation with 340, and 1 workstation with 400. So although everybody has different capacities, what I can give you an output of is 340, or in other words, the capacity of the bottleneck is the entire system's capacity. So the system capacity is 340 units. Well, what is the system efficiency? Well, I can give you 340 units. 1 minute. You can give me 340, but it says here that the actual output is only 300 units. But you told me, no, that the slowest is 340. I will at least give you 340. Then at least give me 340. You are not even giving me 340. I am not asking you to give me a 400, because I know that one person cannot process 400. Then how will I expect 400? But everybody can process 340, no? At least give me 340. You are not giving me 340, which means your system is not running efficiently. Then what is your efficiency? Your efficiency is 300 out of 340 into 100. Why 300 on top? Because you're doing bad. Suppose this was 400, then I would say you are doing good, which means you are more efficient than 100. You are doing bad. I am expecting 300, you are not even giving me 300, you are giving me only 340. So it is I am expecting 340, sorry, but you are only giving me 300. So it is 300 by 340 into 100, which is, how efficient is my system? My system is 300 divided by 340 into 100, which is 88.23% efficient. And those are my answers. Let's quickly look at the solution one at a time. Number one, the bottleneck center is the work center having minimum capacity, hence work center C is the bottleneck center. Write down, the presentation is whatever they say. I am here explaining things to you. Presentation, if they've written well, they've written well. Number two, system capacity is the maximum units that are possible to be produced in the system as a whole. Hence, the system capacity is the capacity of the bottleneck, which is 340 units. And lastly, system efficiency is the actual output divided by the system capacity. Don't remember it this way. Do not confuse yourself. Actual is 300 divided by the system capacity is 340, which is 88.23%. And that's your three answers. Let's come to the next kind of a question, which is again on the same efficiency and utilization lines, but a little different. And it was wrongly printed in the old module or old material. If at all it is wrongly printed in yours also, please make the changes. I'm giving you the proper written solution for it. Question number 8. The following data is available for a machine in a manufacturing unit. So this is the data for a certain machine in a manufacturing unit. Hours worked per day. So the machine is being worked for 8 hours per day. Okay. Next is working days per month. So you're working for 25 days in a certain month. Okay. Number of operators. This is one operator. That's it. Okay. Standard minutes per unit of production. So they've given you the standard time of production. Machine time is 22 and operator time is 8. So that includes a total of 30 minutes. So every unit takes 30 minutes, in which there is a machine element for 22 minutes and a operator or a man element for 8 minutes. If a plant is operated at 75% efficiency and the worker is working at 100% efficiency, what is the output per month? So let's begin with, what time do I have available for production? Well, the time available for production is, I am working for 8 hours a day for a total of 24 days in a month. So available time. Available time is 8 hours into 25 days. 8 hours into 25 days is 25 into 8, which is a total of 200 hours. So I have 200 hours available for production. I have one operator working on an article where the man time is 22 minutes and the machine time is 8 minutes with a total of 30 minutes. So can I say standard time of production, or you can write actual time of production also, is 30 minutes. If the plant is working at 75% efficiency and worker is working at 100% efficiency, what is the output per month? See, in a month I have 200 hours available. But what is 200 hours? Well, 200 hours is 200 into 60. 6 2s are 12, which is 12,000 minutes. Well, 1 unit takes 30 minutes. then I can make X units in 1200 minutes. Cross multiply 1200. The 30 will come down. Divided by 30 is X, or X is 1200 divided by 30 is 12,000 divided by 30 is 400 units. This is my standard answer, that if you give me 8 hours a day for 25 days, which is you are giving me 200 hours, which is you are giving me 12,000 minutes, and it takes on a standard basis 30 minutes to make a certain product, then I will give you an output of 400 units, provided everything is working well. Question number 1 says that the plant is being run at 75% efficiency. What does that mean? What it means is the plant is wasting 25% of the resources. For example, if in the plant I give 100 kgs of raw material, the output will only be for 75 kg, 25 kg will be loss. Why? Because the plant is not working efficiently. If I give a plant 100 hours to function, it will only give me an output for 75 hours because it is only running at 75% efficiency. 25% will be wasted. So on a standard basis, I can make 400 units. But since the plant is running at 75% efficiency, since the plant is only running for 75% efficiency, effective output is 75% of 400, which is 75% of 400 is 300. So if the plant is run at only 75% efficiency, my output will be 300 units. Let's quickly check if they also have the same answer. So the first, what if the plant is being operated for 75% efficiency? Well, let me show you. So 8 hours a day, 25 days is a total of 200 hours. Machine time is 22, man time is 8, so total time is 3 minutes, which they've converted to hours, which is half an hour, which means that in a given month, if you give me 200 hours, I will produce 400 units. But that is if and only if the plant is running at 100% efficiency. The plant is only running at 75% efficiency, so I will only get 75% of the total output, which is 300 units. Done? That is the first part of the question. Let's quickly come to the second part. What is the second part of the question? Well, the second part of the question says that if the machine productivity is increased by 10%. What do you mean by machine productivity is increased by 10%? Let's say initially in the machine there was a certain setting that was taking 8 minutes for 22 minutes for the machine to function. Now I have changed the setting and I realized that it does not take 22 minutes. The efficiency has increased. What will be the output per month? So let me tell you one thing. Initially, it was taking 22 minutes for the machine. Correct? Now, you have increased the efficiency by 10%. You tell me, when efficiency is increased, time will reduce or time will increase? Well, time will reduce, obviously. So if you have increased the efficiency of the machine should take less than 22 minutes to function, which means I need to reduce the time by 10%. Now everybody would say, then sir, simple, do a 22 minus 10% of 22. What is your answer? Your answer is 22 minus a 10%. The answer is 19.8 minutes. So initially the machine was taking 22 minutes. Now it will take only 19.8 minutes. That's wrong. That is not how you increase and decrease time in efficiency questions. How do you do that? Simple. 22. If you have increased efficiency or decreased efficiency, write 100 on 100. If you are increasing the efficiency, then the time needs to reduce. If the time has to reduce, then add the reduction to the denominator. Reduce by how much? 10%. Then your answer is 22 into 100 upon 110. 0, 0 cancel. 11, 2s as 22. 2 into 10 is 20. I'll repeat this. 22. Again, this has to be in your head. You cannot memorize this. This is basic common sense that you need to understand. If you want to increase the efficiency, you said that you've increased the efficiency of the machine. If you've increased the efficiency of the machine, then the machine time will have reduced. If the machine time has to reduce, I have to reduce the 22. And if I have to reduce the 22, write 100 by 100. But to reduce the time, add the reduction in the denominator. So what if I had to decrease efficiency? Well, to decrease efficiency, you would have to increase time. To increase time, inflated by 10%, I would have written the 10% on top. This will become 20 minutes. And that's it. That is the only thing that is told to you. Yes. So new time is 20 minutes on the machine plus 8 minutes for the operator or the man is a total of 28 minutes. Now again the same. In a day, you are giving me 12, in a month, you are giving me 12,000 minutes. So again, 1 unit. If you understand and directly divide, no problem. If you don't, go back to school. There is no there's no shame in going back to your roots. Your basics, if they are strong, there is no problem in going back to them. 1 unit is 28 minutes. So how many units do I make in 12,000 minutes? Cross multiply. The answer is I will make 12,000 divided by 28, which is 12,000. Initially I could make 400 units. Now obviously, because the time has reduced, I can make more. I can make 428.57 units. 428.57 units. Now, before I continue with anything else, let me explain this to you. Remember when we said that I require a machine. So how many machines do you require to complete the capacity? I require 2.5 machines. Well, hello, you can't buy 2.5 machines. Either buy 2 or 3. Well, if I buy 2, I will not be able to complete the capacity, or I will not be able to fulfill the capacity. So I buy 3. Extra is okay, no problem. Well, here you can make 428.57 units. Now people approximate this, and even I think your material also does the same. People say 7 is greater than 5, add 1. 6 is greater than 5, add 1. So according to people, this is approximately 429 units. Well, technically not. In production, no matter what decimal it is, you approximate to the lower end. With machine, you always even if I require to 2.1 machines, I will still say that I need 3 machines. But in production, even if you say that you are making 428.57, you will not say you are making 429. You are making 428 only. Why? How many complete objects have you made? You have only made 428. What about the 429? Well, it's 57% made. The rest, which is 43%, is still unmade. Then can I consider it as made? No. But I think your module also approximates to the upper end. That's it. So let's stop and come back. The first part of the question said, and I want you to pay attention here because I'm going to ask you a question and you have to think for yourself. We are not in class where I will judge you for not knowing the answer. You are sitting home by yourself with your own head. So you should judge yourself if you don't know the answer to this. Anyway, question number 1, 8 hours, 25 days, 200 hours, 12,000 minutes. If I require 30 minutes for 1 unit, how many units do I make? 400. But question number 1 says, but the the plant is being operated at only 75% efficiency. Well, then I say I won't get 400 units. I will get 75% of 400 units. Done? Question number 2. Question number 2 says, if a machine productivity is increased by 10% over the existing level, what will be the output per month? So, machine time remains the same. Sorry, man time remains the same, which is 8 minutes. Machine is becoming more efficient. If it is becoming more efficient, time needs to reduce. How do you reduce time? Not by this method. You do not subtract 10% from it. No. You want to reduce it by 10%? Then divide it by 10. How? 100, 10 plus 10, which is 110. So deflate it by 10%. How do you inflate it? You add 10%. No? How do you deflate it? You don't subtract by 10%. When you are inflating it by 10%, you are making it 110%. So when you are deflating it, you divide by 110. So 110 and the answer is 20 minutes. 20 minutes with 8 minutes of man time is a total of 428 units. Now obviously if the time is reduced over the originally I could make 400 units. Now I can definitely make more, which is 429. My question to you is, should you or will you consider this 75% that they have written in the second question? Should this 75% efficiency be considered in the second question? Should I now multiply this 490.29 or should I take a 75% of the 429? If you ask me, no. If this 75 was written in the main question, then yes, then I would carry it in each and every question. But this 75 is not a main question, it is a part of the sub question, so I cannot take it in each and every question. And that is my problem with the institute solution. My problem with the institute solution is, let's come to the solution. Solution for the second part, which is B. The machine productivity is increased by 10%. Machine time is 22 into 100 upon 10 plus 10, which I told you how, 20 minutes. Total time 28 minutes. They have calculated a monthly production and then taken a 75% of it, which I think is terribly and thoroughly incorrect. Because 75% is not a part of this question, it was a part of the first sub question. In sub questions, I can't carry every criteria to every question. If this 75 written was in the first main question, then I would consider it in each and every question. Now, if they've updated the module, then probably they must have made the change. If they haven't and they've still kept the same, if in your institute material this is what it says, please make it a change. According to me, this is not correct. The 75 was left in the previous question and that's it. If you would have told me to carry it in each and every question, then the answer is correct. Let's come to the third and the last part of the question, and that is, if the operator efficiency is reduced by 20% over the existing level, what will be the output per month? So now you tell me, will you consider the machine time as 20 minutes now? No. See, again, the third question should be related to the original data. So you will not go back to the previous question because that was a sub question. I will go back to 30 and 8 and then I will do whatever I can do in 30 and 8. So let's go back. There was a machine time of 30 minutes, machine time of 22 minutes and operator was taking 8 minutes. Now what are you saying? The operator efficiency is reduced by 20%. So see, if you are reducing the operator's efficiency by 20%, time should increase because more time is less efficiency. If he is less efficient, he should take more than 8 minutes. So I will say since operator efficiency is reduced by 20%, the new operator time will be 8, 100, 100. You want to increase the time or decrease the time? Increase. By how much? 20%. Then add the 20 to the numerator. And that's your answer. It is 8 into 120 upon 100. What is 8 into 120 upon 100? 8 into 120 divided by 100 is 9.6. So the answer is 9.6 minutes. So I will say new time of production is 22 minutes on the machine, and 9.6 minutes on the man. So 22 plus 9.6 is a total of 31.6 minutes. Is 31.6 minutes. Now obviously without any question I was making 400. When you increase the operator efficiency, the machine efficiency, I was giving you a more output. Now if you reduce the man efficiency, I will give you lesser than 400. How much? 1 unit takes 31.6 minutes. So I will make X units in 12,000 minutes. X is equal to 12,000 divided by 31.6, which is 12,000 divided by 31.6 is 379.74. So I will make 379.74 units, which according to me should be approximately 379 only, but your institute material approximates it to the upper end. So the answer should be 380. Let's come back to the solution that they have written. Solution number 3. I'm showing you this so that when you look at the material also, you should be familiar. Again, my problem. You have again taken a 75%, which I don't think should be required. If this was written in the original question, then I agree you are taking a 75% everywhere. This is not in the main question. This is in the sub question. Why will you consider it everywhere? But they have. But now you remember, if it's not mentioned in the main question, don't. If it's mentioned in the main question, then apply it everywhere. That is it. That according to me is question number 8. Let's move on to one last question I think that is left. Now the next question that I want to do, which is the last question, like I said, question number 9, is a very loaded question. Again, we can't really help it. I told you every question they have kept is of different type. There were similar questions, there were 3. But this question circulates around the steel question, which is 50,000 tons of design capacity, 40,000 tons of 40,000 tons of effective capacity and 36,000 tons of actual capacity. So this goes around that pattern, but the understanding is a little different. So I want you to pay attention. The following data is available for a manufacturing unit. So there's a manufacturing unit, and for that manufacturing unit, this following data is given. What is the data? Number of operators 15. There are 15 operators in that manufacturing unit. Daily working hours is 8. So every person is working for 8 hours. and in a month they are working for 25 days. Okay. Standard production per month is 300 units. This is the standard that is set. Standard labor hours per unit is 8. Standard labor hours required is 8. Okay. Next, the following information is obtained for November 2015. Man days lost due to absentees. So what has happened? 30 man days are lost due to absentees. Okay. Units produced is 240. Okay. Idle time is 276. What are they asking you? Number 1, what is the percentage of absentees? Number 2, efficiency of utilization of labor. Number C, productive efficiency of labor. And D, overall productivity of labor in terms of units produced per month per man. So this is very clear. You know what they want? They want an input-output productivity. They want you to tell them how many units are produced per man per month. So by one man every month, how many units are produced? Okay, let's come back to the data and let's start writing down one thing at a time so that we have everything in front of us so that we can begin the solution. Number of operators is 15. So 15 operators working 8 hours per day for 25 days per month. So can I do one thing? Can I find out how many total hours does this become? How? Can I say 15 operators working for 8 hours and working for 25 days is a total of 15 into 8 into 25 is 3000 hours. Fine, fantastic. Next, what is the standard output that you are expecting? Well, standard output expected is 300 units. Okay. Standard labor required is 8 hours per unit. Okay. What other data have you given me? Well, other data is man days lost due to absentees. Well, obviously all 8 people are not going to be present for all 25 days. All 15 people, sorry, are not going to be present for all 25 days. Someday somebody is going to be absent. So due to absentees, I have lost 30 man days. Okay. The actual units produced is 240 and the idle time is 276 man hours. Okay. So can I do one thing? See, this is in hours. This is in hours. Why keep this in days? Can I say absentees is 30 man days, which is 30 into 8. 1 day is 8 hours. So if I have lost 30 man days, how many hours have I lost? 3 8s are 8 3s are 24. 240 hours. Question number 1. What is the percentage of absentees? Well, see, I have employed 15 people for 8 hours for 25 days. I am expecting an output of 3000 hours in total. But out of which 240 hours you are absent. So the percentage of absentees is 240 out of a total of 3000 into 100. What does 240 into 100 divided by 3000 become 8. So I have lost 8% of time due to absentees. Question 1 is solved. This is exactly like the steel plant question. They are asking you to find efficiency of utilization of labor and productive efficiency of labor. You know what? These are two ways of just saying the same thing. Efficiency of utilization means utilization, and productive efficiency is nothing else but efficiency. So they are asking you to find B, utilization, and C, efficiency. What did we have in the previous question for utilization and efficiency? Well, we needed three things. One is a design. The next was an effective. And the last was actual. So remember, we said design was 50,000, effective was 40,000, and actual was 36,000. So we said efficiency is, I'm not expecting a 50,000 from you. I'm at least expecting 40, but you are only giving me 36. So it is 36 by 40. And when you ask me utilization, it is actual against the total design, where I need to find out where all I'm falling short. So it is going to be 36,000 against 50,000. Bottom line is, I need three things. What is your design made of? What should you effectively get? And what are you actually getting? Let's come to one thing at a time. Well, I have created a design of 15 operators working 8-hour day for 25 days is a total of 3000 hours is my design. What do you effectively get? Well, I should get 3000 hours. No. Do you notice that in these 3000 hours, there are 240 hours that are lost due to absentees? And there are another 276 lost due to idle. Why would you judge them when they are absent? And why would you judge them when they are idle? I should judge them when they are idle. Why are they sitting idle? They are sitting idle because there is no electricity. What will they work? The fuse has blown off. How will they work? The machine has stopped working. How will they work? You called for a meeting. How will they work? You called for a fire drill. How could they work? So you cannot judge them for all 3000 hours, because in these 3000 hours, 240 hours they have been absent and 276 hours they have been idle. So if you want to know effectively how much you will get, you should get 3000 minus the 240 that is lost due to absentees and the 276 that is lost due to idle, which is 3000 minus 240 minus 276 is a total of 2484. Expect an output of 2484. That I will give you. See, 3000 I can't give you because what will I do, sir? I am the floor manager, but 240 hours are lost because of people being absent and because of light problems and raw material unavailability and fire drills and safety trainings. I have lost 276 hours which I have put into idle. So effectively, I can give you an output of 284. Fine. What have you actually given me? You have actually given me an output of 240 units. Okay. One unit takes 8 hours. So your actual output is worth 240 into 8 hours, which is 240 multiplied by 8 is 1920 hours. What? See, I designed you for 3000. You don't give me 3000. You say, sir, I have lost 240 because of absentees and I've lost 276 hours because of idle. I understand. Okay. At least give me an output of 2484. That also you are not giving me. You are giving me an output of or output equivalent to 1920 hours. So if you ask me how efficient is my system working? Well, I am getting 1920 where I should get at least 2484 into 100. So 1920 divided by 2484, multiply that by 100 is 77.29%. 77.29% efficiency. How well are you utilized? Well, utilization is the actual against the design. I am getting 1920, but the designed is 3000. Arey sir, but absentees, idle, I don't care. I designed for 3000, no. Then now you find out why are people absent? Why are they idle? Reduce the idle. Get control on them. Reduce the absentees. This is a total of 1920 divided by 3000 multiplied by 100, and that is 64%. So my system is 64% utilized. Well, it is 77.29% efficient. Let me quickly repeat this. The question says 15 operators working for 8 hours a day for 25 days a month is a total of 3000 hours that they should be working. Now in this, I am expecting a standard output of 3000. It's okay. You are expecting standard of 3000. I don't expect standard of 3000 because it's not compulsory that you are working for those many hours. The standard is 8 hours, but I am losing time due to absentees and I am losing time due to idle. And eventually, actually, I am getting 240. Okay. Idle time is 276 man hours. Fine. So if you are asking me percentage of absentees, 240 hours lost out of a total 3000 in absentees is a total of 8%. Okay. Now I want you to find efficiency of utilization of labor and productive efficiency of labor. Well, efficiency of utilization of labor means utilization, and productive efficiency of labor means efficiency. To find efficiency and utilization, I need three things. What have you designed your plant for? What is the effective that you should get? And what is the actual that you are getting? Well, I have designed this plant for a total of 3,000 hours. But in those 3,000, I lose 240 hours due to absentees and I lose 276 due to idle. So I can't judge my workers for these total of, if I am correct, 516 if I am correct. For these 516 hours, why can't I judge them? Because it's not their fault they are not working. No, they are absent. They could be unwell. And they are idle because it could be my fault. No light, no machine working. So I can't judge them for these hours. So okay, from the 3000 I remove 2484. So I expect you to give me an output of 2484 hours. You are actually giving me 240 units as an output in that month. Okay. 240 units is equivalent to 1920 hours, which is wrong. If I'm expecting 2484, at least give me, don't give me 3000, at least give me 2484. That also you are not giving. You are giving me 1920. So I have designed for 3000, my effective is 2484 and my actual is 1920. If you ask me how efficient my workers are, then I will judge them for the time attended against the actual output. The time attended is 2484 against the actual, which is 1920. So 1920 by 2484 into 100, which is 77.29%. And if you are asking me how well am I utilizing them, but I am only utilizing them for 1920 hours when I should be utilizing them for 3000 hours. So it is 1920 by 3000 into 100. Let's come to the last question. Overall productivity of labor in terms of units produced per man per month. Well, see, I have 15 men working for a month that are giving me an output of 240. So, productivity per man per month is 240 units produced by 15 men is 240 divided by 15, which is 16 units per man per month. That's the final answer. Let's quickly look at the solution that they have so that we can match it with ours. They have also written the question pretty well. There isn't much missing in it. It's just that they have written a few things directly. So I have written them in a full flow. You can use my solution. So number one, percentage of absentees is 240 into 100 by 8%. Don't check out there. 8% ours is also 8. No, fine. Efficiency of utilization of labor is 64%, which I also got the same. My efficiency of utilization, which means utilization, my utilization was also 64%. My efficiency was 77.29%. Let's check that. Is your efficiency 77.29%? Yes, see, efficiency is here 77.3 because 29 they've approximated to 3. But don't pay attention to, see, 516 hours lost is what I had said. Anyway, that's your answer. And lastly, productivity. Productivity is 16 units. Now see, here they've written extra. 15 men produce 300 units. 300 is standard. So the standard is 20 units, but you are actually getting 16 units. So they are saying productivity has fallen. If you would have told me, I would have calculated the fall. You didn't tell me. You only said calculate the productivity, which I did. If in the question you would have mentioned and then compare with the standard, then I would have said yes. According to standard, there should be a 20 unit productivity per man per month. But then it's only 16, which means there is a 25% loss, which is 16 upon 20 into 100, which is 75%, which means it is fallen by 25%. So that you can write down extra. I am leaving the solution, like the whole solution, for like a bunch of seconds so that you can have a look at the solution. So whenever you pause and you are writing everything down, you have everything on one page and you have the solution with you. So yes, perfect. This is the solution. Pause it and then copy this down. 15 operators working for 8 hours per day for 25 days a month is a total of 3000 hours that has to be clocked in. The standard output is 3300. It's okay. I'm not expecting you to give me a standard because you may not be working for those many hours every month. Standard labor is 8 hours per unit. Okay. Absentees 30 men days lost, which is 240 hours lost. Actual output is 240 units and idle time is 276 hours. Percentage idle is absentees is 240 hours of absentees, 240 hours of absentees against the total of 3000 is 8%. Efficiency of utilization of labor is nothing else but utilization, and productive efficiency is nothing else but efficiency. For this, I need design, effective, actual. Always work this way. Design is 3000 hours. Effective is 2484 hours. From the design, I remove the idle and the absent. And you are actually giving me 240 units into 8 hours is 1920 hours. So effective or efficiency is the actual by the effective into 100, and utilization is the actual by the design into 100. And the answer is productivity per man per month is 240 by 15, which is 16 units. And then they've written how it's fallen. So pause this and copy. This is my solution. So with this, all the questions of production planning and productivity management, capacity planning and productivity are done. Again, what we do always is run through the question paper and check how many times are these questions asked. So let's come to question papers. So let's begin then. Topic number 4, if I'm correct, is going to be capacity and productivity. Let's come to one question paper at a time. True or false, MCQs. Yes. Question 2A, B, no. Question 3A, B, no. Question 4A, no. Question 4B, yes. An incentive scheme allows proportionate production beyond 100% performance level. Calculate the amount of incentive bonus of number 1, incentive bonus, number 2, total payment received by an operator on which the few particulars apply. What are the particulars? Operation assembling of table clock set. So here it is table clock and not pocket transistor. Okay. Working contents 40 standard minutes. There it is 30, here it is 40. 8 hours of attended time, of which 3 hours is unmeasured. See, they changed the ratio. 8 hours and becomes 3 hours of unmeasured, that becomes 5 hours of measured. Number of sets assembled during the day, 10. Wage rate is rupees 5 per hour. Question number 3, what is the net labor productivity achieved by the operator during the day? Okay, so exactly the same questions asked. Fine, let me first quickly write down the data. And the data is that you are working for 8 hours, out of which 3 hours is unmeasured. So that makes 5 hours as measured. 5 hours is 5 into 60 minutes. 5 6 are 300 minutes. Now standard time is 40 minutes. So 1 unit gets made in 40 minutes. Then I will make X units in 300 minutes. So the answer is 300 divided by 40 is X, or X is 300 divided by 40. 300 divided by 40 is 7.5. Now this is a little odd. You can't make 7.5 units. But because we are doing a calculation, you will have to keep it at 7.5. So standard, I expect 7.5 units made in that day. Let's come to what your actuals are. You are actually assembling 10 sets that day. So actual is 10 sets. So productivity, if you ask me, is you are very good. So it is 10 by 7.5 into 100, which is 10 divided by 7.5, multiply that by 100. It is 133.33333, 133.3333%. So I'm not writing in detail. I want you to write in detail. 8 hours that you work, out of which 5 hours is measured, 3 hours is unmeasured. So for both, I will give you, what are you asking for? You are asking for 5 rupees per hour. Okay. So for both, I will give you 5 into 5 and 3 into 5 rupees, which is 25 and 15 rupees. But because you are doing better than what I am expecting of you, I am giving you a bonus. How much? A 33.33% bonus. So bonus will be 25 into 33.33%. So it is 25 into 33.333%, which is 8.33333. So it is 8.3333 rupees is your bonus. So total salary will be 25, which is the measured salary, 15 is the unmeasured salary, and the bonus is 8.333. So your total salary is going to be 8.333 plus 25 plus 15 is a total of 48.33333. And this is your answer. Make sure you make these solutions immediately after the chapter so that you have them ready. Productivity achieved by the operator. Again, so productivity will be in a span of how many hours? In a span of, where did it go? In a span of 5 hours. You are giving me an output of how many units? 10 units. So productivity is going to be 10 by 5, which is 2 units per hour. Is your productivity of the operator. 3 questions, 2 marks each, 6 marks. Make sure you have the solution right then and there. So let me make a note of this, and that is one question on productivity asked. One question on incentive I'm writing so that it's easier to remember. One question on incentive was asked for a total of how many marks? 6 marks. Okay. That is the June 17 question paper. Question 5, no. AB, no. Done. Let's come to the December 17 question paper. So December 17 question paper, fantastic. Question 2A, no. Question 2B, yes. A firm has 4 workstations and with individual capacities of in units per day. Okay. This is the workstation. Haven't we done the exact same question some time ago? Yes. And then I'll show you something which is mind-boggling. 400, 310, 370, 340 and actual is 260. Identify the bottleneck. What is the lowest? B. Then B is the bottleneck operation. What is the system capacity? Well, 310 is the maximum they can make, so it's 310. What is the system efficiency? Well, system efficiency is, I am expecting 310, but I only get 260. So it's 260 by 310 into 100. My point is, look here. They've asked you 3 questions, each for 3 marks is a total of 9 marks. Imagine they're asking this for 9 marks. Make sure you have the solution behind the book. I'm not doing the question. So that is one question for 9 marks in the December 19 paper. Let me make a note of that. One question on bottleneck asked for 9 marks. Fantastic. Let's move on. Then question 4. That was question, yes, that was 2A. 3A, no. 3B, no, is a queuing theory question. 4A, no, sequencing question. 4B, yes. This is a capacity question. Number of machines. Same question, see, exactly same that was there in the material. The only difference is, what have they changed? They have changed 8 hours and 285 days. But then ABC 3 machines, their annual demands are given and per unit time is given. Processing time for ABC is asked. Fine. After that, annual production capacity of one machine is asked, which is going to be 8 into 285, and number of machines, which is what you want against what you have. 6 marks. So can I say same question paper this was? Yes. If I'm right? Yes, this was in the same question paper. The number of machines question. So one question, number of machines is asked for 6 marks. So 15 marks in this paper. Let's continue. No, question number 5 is not asked. Question number 5B is also not asked. Fine then. Let's move to the next paper, which is the June 18 paper. In the June 18 paper, question 2A, no. 2B, no. 3A, no. 3B, no. 4A is no assignment problem. 4B is queuing theory. If I'm right, yes. Yes. 5A is no sequencing. 5B is again no breakdown maintenance. So nothing asked from this chapter in the June 18 paper. Let's come to the December 18 paper. In the December 18 paper, 2A was done already, forecasting. 2B, sorry, is done already, is forecasting. 3AB is theory. 4A is transportation, so no. 4B is simulation, so no. 5A is network, and 5B is maintenance management. So no and no. That's it then. No questions asked in that paper also in the December 18. Let's come to the June 19. June 19 2A. Sorry. June 19 2A. No. 2B. Yes, and I gave it to you in writing yesterday. That this was the same question. We've done this in location planning. For 10, and I told you for 10 marks they've asked you this question. 10 marks. Anyway, let's move on. 3A, no. 3B, no. 4A is an assignment problem, so no. 4B is a queuing theory problem, so no. 5A is a sequencing problem, so no. 5B is a maintenance managed problem, so no. So can I say not asked? Let's go to the last question paper, which is the December 19 question paper. In the December 19 question paper, fantastic. 2A, no. 2B, yes. This is 2B. Exactly the same question and the same questions that are asked. So I want you to do this for behind this. I'm not going to do it for you. But here they have asked it for, yes, again 9 marks. So question number 1, what is the bottleneck? What is the lowest? 350 is the bottleneck. Capacity 350. System efficiency 350, 310 divided by 350 into 100. That's it. So let me make a note. One question on bottleneck for 9 marks. Okay. Immediately after that, if you see 3B is a question that we just did some time ago. And that is number of operators, daily working hours, number of months, standard production, number of hours worked, the number of days lost due to absentees, units produced, and the idle time. With all this, and all the questions asked are exactly the same. And this question is asked for a total of 8 marks here. So I'm not going to do it for you. You are going to do it. Let me make a note. One question on absentees is for 8 marks. So that is it then. That's the last question paper that we have. With this, the paper discussion is also done. So yes, whenever they ask for a lot of marks. Otherwise, it's not asked in patches. Fine. So this is it then. This is capacity and productivity management. I will see you in the next session. Thank you.